All right, we are now moving into our next unit, and this is going to basically bring us into our last topic of the school year. We're going to be looking at a very different sort of set of problems in this last final unit. This really is kind of broken into two parts, but the two parts are related. The first part, what we're going to start today, is a sort of a little mini unit on series and sequences. This is something that you've started to explore before back in middle school math and things like that. And in this particular video, we're going to focus on just introducing sequences. And so this is going to be very basic level. In fact, it probably will feel a lot like middle school math. But we will move this up to the high school level pretty soon. When we're done talking about series and sequences, we'll talk about probability and counting. The two topics are somewhat related, but perhaps at our level and for our class, the relationship between those two things might be a little bit clouded. We'll see what happens when we get there. And then we're done with the year. Those are our final two topics, and that'll be it for our class this year. So with all of that said, let's get started by introducing sequences. When we look at our learning objectives on this video, you can see that there are three. Know what a learning or know what a sequence is. And again, we're talking about just a working definition, a basic understanding. You don't need to be able to write something down word for word. You need to be able to find and describe the patterns. So make sure you understand that. It's find and describe. Find and describe the patterns that go with a sequence, and then find terms that are missing from a sequence. Okay. So here we go. Let's get started with what is a sequence. Okay. Cool. What is a sequence? Or maybe a question mark might be what's appropriate there. What is a sequence? Okay. Let's start with a definition. There actually are a couple different ways that sequences are defined, but this is the way that we're going to define it for our class. This is, for our purposes, this will be the best definition. A sequence is, excuse me, a set of numbers. And you know what? Actually, it doesn't even have to be numbers. In our class, it will always be numbers. But generally speaking, that's not true. You could have a sequence that's made up of shapes or other things as well. So let's just say a set. A set that has been arranged in a specific order. Okay. A set. And remember, a set is a collection of things, right? So I'm going to, and in our class, it will always be numbers, but I didn't want to get too specific because a sequence doesn't have to be numbers. Excuse me, just like a set doesn't have to be numbers. But in our class, every set that we've studied has been numbers. That's irrelevant. So a set, that's just a collection of things. So we're going to have a collection of numbers that have been arranged in a specific order. And what I mean by specific order, it means that there's a first number, and then there's a second number, and then there's a third number. So all the items in the set have been placed so that there's one that comes first, and then there's one that comes second, and then there's one that comes third, and then there's one that comes fourth. And then depending on how many things are in the set, it just goes on from there. But they've been placed in a specific order. Excuse me, and that's a sequence. Now, there are two kinds of sequences, at least as far as our class is concerned. There's actually more than two, but for this video, we're going to look at two very broad general types of sequences. And that is a finite sequence, and an infinite sequence. And if you're familiar with the term finite and the term infinite, then you probably know what these two things are. You can probably guess. A finite sequence does not go on forever. There's not only is there a first term, every sequence has a first term, but a finite sequence also has a last term. Okay, so it does not go forever. Forever, I think, is really one word, isn't it? Forever. AKA has a first and a last term. Okay, has a first and a last term. But a finite sequence does go on forever. And so it will have a first term. because every sequence has a first term, but it does not have a last term because it goes forever. Okay, so these are the two types of sequences, at least in this point of our class, that we're going to talk about. I will say there are other ways to classify sequences, and later in our class, we will talk about some of the other ways to classify sequences. But for today, for this video, those are the two that you want to be sure you're good with. A finite sequence starts and stops. It has a beginning and end, has a first and a last. An infinite sequence goes on forever. All right. What is a sequence? It's just things that have been placed in a specific order. Okay. In other words, there's a first thing, there's a second thing, there's a third thing, so on and so forth. So let's take a look at some examples of sequences. Okay. The maybe most easiest, obvious example is just counting. That is a sequence. There's my first number. My first number is a 1. And then my other numbers have been placed in a specific order. I put the next smallest number next, and then the next smallest number next, and then the next smallest number next. And I've just arranged them from smallest to largest. So I've placed them in a specific order. Now, I will say it's not necessarily important that you can always describe the rule that has been used to place them in order, okay? But as we get started here, that is the first type of problem we're going to explore. We're going to talk about how would you describe this pattern. And so in this particular problem, if I was going to describe the pattern, what I would say is that the pattern is that you add 1 every time. Now, how do I get that pattern? The way that I get that pattern is by looking at how do I go from this to this? How do I go from here to here? How do I go from here to here? And I need to make sure that whatever rule I think moves me from here to here, that same rule works for every single set of, or every single pair of numbers. So this is +1, this is +1, this is +1. And so because that does seem to work for every single set of numbers, I'm going to say the pattern is add 1. Okay. Of course, we can have things that are more complicated. So think about this pattern for a second. 3, -6, +12, -24, +48, -96, ... Okay, now, the first thing I want to mention real quick is some people might be confused by this ... So here's example number 1. It just stops. There's nothing after the 6. But here in example number 2, after my -96, there's this ... Okay. Well, that ... you don't need to know the name of it. It's called an ellipsis, but we don't need to know that name. What we need to know is the ... means that this pattern that exists right here, that pattern continues. That's what the ... means, is that the pattern continues. So because it's at the end of my sequence, it's telling me that this is an infinite sequence. If the pattern continues and I can't see where it stops, this is an example of an infinite sequence. Here, my sequence actually stopped. So that's an example of a finite sequence. Okay, but now that we've seen an example of a finite and an infinite, let's go to this one and let's describe its pattern. Let's describe its pattern. All right. So here I can see if I try adding numbers, it doesn't work because I can't add a number from 3 to get to -6 and then add the same number to get from -6 to +12, right? That wouldn't work because to get from 3 to -6, I'd have to add a -9. But -6 plus -9, that would give me -15, not +12. So this doesn't work. So the pattern must not be adding. Maybe the pattern is multiplying. So if I were to multiply to go from 3 to -6, I would have to multiply by a -2. To go from -6 to 12, well, hey, if this is times a -2, notice this one is also times a -2. 12, a +12 times a -2, that equals -24. So this seems to be a situation where the pattern is multiplying, and specifically, I am multiplying by a -2. Okay, so one thing to keep in mind as you're looking for patterns, the pattern could be adding, the pattern could be multiplying. So you'll have to explore both of those. You might be working with positive numbers, you might be working with negative numbers. You've got to be ready for both of those. And of course, don't forget when you're looking for patterns that fractions are numbers too. So let's finish with one last example. Whoops, this would be example 3, where we're asked to describe the pattern. Okay, so here's another example where we're describing the pattern. So let's suppose I start with 1, and then I have a 3/2, and then I have a 9/4, and then I have a 27/8, and then an 81/16, and then a ... Okay, so again, this is an example of an infinite pattern or an infinite sequence because the ... at the end tells me the pattern keeps going. But all we need to do is describe what the pattern is. So how do I go from here to here to here? Well, I can see that I'm working with fractions. And when you're working with fractions, in my personal experience, the easiest way is to find 2 separate patterns. Look to see what's happening in the top, and then look to see what's happening in the bottom, okay? You can try to work with the whole fraction and see what happens. Maybe working with the whole fraction is nice if it's like adding or subtracting. So I could try this. If I were to do, 1 plus 1 equals 3/2. Well, it'd be 1 plus 1/2 equals 3/2. But 3/2 plus 1/2 equals 2, not 9/4. So I'm not adding, and I could try subtracting, but subtracting doesn't work because I have to add to go from 1 to 3/2. Okay, so in that case, if adding and subtracting don't work, I would move on to multiplying or dividing. But if I'm doing that, then I would work with the top and the bottom separately, because remember the rule for multiplying fractions, if I have 2 fractions that I'm multiplying, the rule for multiplying is you multiply the top and you multiply the bottom. So because of that, I personally think the easiest way to look for patterns where you're multiplying with fractions is just think about the pattern on the top and think about the pattern on the bottom. Also, don't forget that anything that's a whole number can be written as a fraction by putting it over 1. So really what I'm going to do is think about what's 1 to 3 to 9 to 27 to 81. What's my pattern there? Well, I'm timesing by 3, and I'm timesing by 3, and I'm timesing by 3. So it looks like the pattern in the top is to multiply by 3. And then in the bottom, from 1 to 2, 2 to 4, 4 to 8, looks like in the bottom, I'm multiplying by 2 in the bottom. So if I'm multiplying by 3 in the top, and I'm multiplying by 2 in the bottom, then overall, what I'm multiplying by is 3/2. Okay, so this is the type of thing that you'll be working with in the homework with this, just simply finding a way to describe the pattern. Now, that's only half of most of the problems that you'll do. The other half that you'll need to do is then, once you can describe the pattern, find pieces that are missing. All right, so let's take a look at example number 2 here. But I'm going to turn it into example number 4. We already know what the pattern was on this from example number 2. The pattern was that we were multiplying by 2. I'm sorry, multiplying by -2. So then the question might ask you, not only figure out what the pattern is, but the question might ask you, figure out what the next 2 numbers are. Okay, well, that's pretty straightforward. If it's just simply the next 2 numbers, once you know that the pattern is to multiply by -2, then all you have to do is pick up with the last number, multiply it by -2, and there's what comes next. And then multiply that by -2, and then there's what comes next. Not a very big deal if they ask you to find the next 2 numbers at the end. But suppose they ask you to find some numbers from the middle. So let's finish this with a brand new example where they want us to describe the pattern. So I'm just going to put describe the pattern. Okay, describe the pattern and find the missing numbers or the missing terms or whatever you want to call them. Okay, so here we go. Here's our pattern. So let's suppose that I've got, I start with a 2. Sorry about that. And then there's a missing thing. And then I have a 10. And then there's a missing thing and another missing thing. And then I have a 22. And that's the whole thing. That's all I've got. Okay, so finding the pattern here can be a little tricky. Now, here's the thing that I'm going to do to be nice to you. In our class, we will try to limit ourselves as much as we can to patterns where you're either adding or subtracting. And I call that, basically the same thing, right? Because subtracting is the same as adding a negative. So adding or subtracting. Or the other thing that we'll say is multiplying and dividing. And again, I call that the same thing because dividing is the same as multiplying by a number less than 1, like a fraction, right? Okay, so multiplying, dividing, adding, subtracting, whatever you want to, we're going to look for those two things. Now, if the problem is more straightforward like this one, we might pull in some things that are more sophisticated than just adding and multiplying. But in a situation like this, I'm going to be nice to you. And really all you need to check for are find things that are adding or find things that are multiplying. Okay, now, so here's what I would do. I would start with adding because that is, typically speaking, the easier route to take. And in this case, I can see that I have added something twice, right? Because it has to be a consistent pattern. I've added something twice to get to 10, okay? Now, what I can do to try and figure out what that is I can say, okay, how far is it from 2 to 10? Well, 10 minus 2 equals 8. So this whole thing is 8. But I did it in 2 jumps. So if I take 8 and I split it in half, that would be each of those 2 jumps. So this would be, if that's true, this would be a 4. And this would be a 4, because that's what gives me the total jump of 8. So maybe this is a 6. Now, that works for my first blank, but does it keep working? Because remember, the pattern has to stick. It has to stay. So if it's going to keep working, then I should be able to add 4 again. So 10 plus 4 would be 14. And I should be able to add 4 again. 4 plus 4 would be, or I'm sorry, 14 plus 4 would be 18. And now here's the test. If I add 4 again, is this the number that I should end up with? And in this case, it is. That is the number. So you can see on this, there's a little bit of sort of guess and check. I started by guessing that the pattern was adding. And then I figured out what number I must have added. And that becomes my guess. And then I just keep using that pattern over here. And then I check to see if this is the answer that I got. And on this problem, that worked. If it didn't work, then I would move on to trying a multiply or a divide or an add or a subtract or whatever. So this is the basic idea. If there are numbers that are missing, what you can do is look to see what is the full jump that we've got here, and then we can break that jump up into little pieces, okay? So this is what we're looking at if the missing spots are in the middle. Missing spots at the end, no big deal. That's definitely like something you would have done back in middle school, maybe even elementary school. Missing spots in the middle, a little trickier. All right, but that is really all that we've got for this first video. Be able to describe a pattern, be able to fill in missing pieces. Most of the patterns that we're going to work with are either adding or multiplying, and again, subtracting, dividing, in my opinion, same thing. And we've talked about what a sequence is. So that takes care of the learning objectives for this video. Thanks for watching. Have a good one.